This is a podcast by sciencemag.com.
Science man, come out and play. Science man, come out and play. Science man, come out and play.
Hello, dear English-speaking, reading, hearing listener. Welcome back to me at Science Mag, written Science MUG, the blog-podcast-Twitter and Instagram accounts-entity behind the unsuccessful eShop Stuff and Go on Zazzle.com, which hasn't been uploading any episode since a while because it's been busy chasing a unicorn all over the web, only to eventually find out it was indeed the offspring of an albino rhino and a particularly kinky white horse. And that speaks to you thanks to the voice kidnapped via voodoo wireless trick from a very, very dumb human. And which does all of this in English ? Language that is to proper English what this is to a regular episode, and I am to a successful podcast, blog and eShop. I have indeed read a lot of science news and papers in these weeks. Yes, in spite of my lack of brain, I have found myself able to read. Oh, incredible. But because of the paywall of many science journals, and above all of my laziness, I didn't make episodes out of them, but only mini to micro posts and related cartoons for the blog side of my silly self. If you want to check them out, you can find the links in the summary window of this episode. So, dear listener, in this sort of episode, here are for you not one, not two, but three of the science mini to micro stories I have told via cartoons to your pals, readers. Here we go!
Science Mag!
News 1. Bumblebees face extinction, and one of the main causes is human-driven climate change. These are the results of a study on long-term data about 66 species of bumblebees buzzing in North America and Europe. The study has been performed by 3 scientists from the University of Ottawa, Canada, and the University College London, England, UK. According to the researchers, climate change induced the high rise in frequency of extremely hot days reduces colonization and site occupancy by bumblebees, increases local extinction rates, and decreases species richness within a region, independent of land usage, change, or condition. Besides, the researcher said, this very same mechanism may also contribute to the general biodiversity loss. And, dear listener, this biodiversity loss thing would be pretty bad for you humans. Specifically, without bumblebees and bees in general, well, you'll find yourself very much in trouble. Besides being left with just a character from crappy sci-fi movies and no more actual adorable little bees. According to the Food and Agriculture Organization of the United Nations, the FAO. Indeed, it is estimated that about 1/3 of all plants or plant products eaten by humans are directly or indirectly dependent on bee pollination. More than half of the world's diet of fat and oil comes from oil seeds such as cotton, rape, sunflower, coconut, groundnut, and oil palm. Even though some of these have special pollinators belonging to the other types of insects, these plants all depend on or benefit from bee pollination to some extent. In addition, many food crops and forage for cattle are grown from seeds of insect-pollinated plants. Moreover, a 2017 study by Miller, Stratman et al. Says that the decline in bee pollinators and therefore their services to flowering plants worldwide can potentially negatively impact more than 85% of flowering plants and of course human health too. The losses for the agricultural compound alone would be over $200 billion per year globally, namely almost a third of Switzerland or Saudi Arabia GDP. And the costs from diminished pollination services in wild ecosystems would most probably be way higher. Just to make some examples, dear listener, a 2019 research paper by Wangbaum et al. Reports that without bee pollination services there won't be any more superior quality apple, strawberry, cucurbits, citrus, mandarin, apricot, blackberry, blueberries, and so on. News 2. Since I just mentioned blueberries, well, a group of researchers in Minnesota, USA, for the first time ever observed an adult wolf giving blueberries to pups as food. The wolf actually regurgitated the berries to feed them to the pups. According to the scientists, their findings suggests wild berries might be a more valuable food source for wolves in southern boreal ecosystems than previously appreciated. Wolves, indeed, usually primarily feed their pups with the remains of the carcass of their prey, which are other mammalians. News 3. The about 600 light years far away Betelgeuse red supergiant, destined to go supernova in probably some tens of thousand years, keeps to gradually decrease in brightness, less 25% since just last September 2019, and astronomers don't exactly know why, but they think it could be due to changes in the envelope outer convection atmosphere of the star. Betelgeuse names is a corruption of the Arabic Yad al-Jawza, which means the hand of al-Jawza. Al-Jawza being the name of the figure ancient Arabs were seeing the star constellation, probably a woman. The constellation in question is the Orion 1, or Orion in English, and Betelgeuse is one of the two brightest stars of it, the other being Rigel, with the couple also called respectively Alpha and Beta Orionis. Betelgeuse's brightness is indeed between 80,000 to 100,000 times that of the Sun, and its radius is at least double the size of the Martian orbit, but it could even be as big as the orbit of Jupiter, about 1,000 times that of the Sun, while its mass at its birth was probably 18 or 19 times that of the Sun. Now, dear listener, let's cover some very basic infos to fully get why a strange star like Betelgeuse is getting dimmer and not brighter. For a starter, let's refresh our notion of what's light years, okay? Just so to better grasp how far Betelgeuse actually be. A light year is the distance light travels in a year. It's about 9.5 thousand billion kilometers. That is about 5,900 billion miles. It is more than 60,000 astronomical units. That is 60,000 times the distance between Earth and the Sun. Basically, if in a parallel reality New York were the Earth and Beijing were the 6,000 light years far Betelgeuse, well, the extent of a single step made in that parallel reality by you, dear human listener, would be enough to take you to the moon in this very actual reality of yours. Now, let's go to the star itself and its mysterious dimming. Betelgeuse is a red supergiant. How a star gets to be a red supergiant? Well, you know how stars be giant balls of gas, where deep in their guts nuclear fusion of hydrogen atoms occurs and therefore helium-1s are formed. The energy coming from such deeper parts of the star is what ultimately provides the pressure needed to keep the stars from collapsing under its own weight, and it's also what makes the star a shining thing in the space. As long as the star uses hydrogen as fuel, thus producing helium, well, it is stable, and it is classified as a main sequence star, which is a star in the stable part of its lifespan that, depending on the star, usually, but not always, lasts billions of years. But what happens when a star runs out of hydrogen in its core? Well, then its core begins to collapse and gets hotter. So the starving star counters its core's collapsing by expanding its outer envelope and therefore its overall surface. This makes the expanding star's surface temperatures to go pretty down and the star's luminosity to go pretty up, to increase. In other words, it gets much brighter. And dear listener, this is the time when a star becomes a red giant. Now, at this point, as mentioned, the star's core has no more hydrogen, right? But it has helium, previously produced by the fusion of hydrogen atoms. And, as said, the core temperature has risen, so now the core is hot enough to ignite the fusion of helium's atom into heavier stuff. Besides, right outside the star's core, there's still some hydrogen, and at this point, surrounding the star's hotter and hotter core, there's now a shell, which is in turn reaching itself a temperature temperature sufficient to ignite the fusion of the remaining hydrogens into helium. So more helium is produced in this hot shell around the core, and this brand new helium then falls onto the core where it becomes more fuel. Now, dear listener, this red giant's phase lasts much less than the main sequence phase, just a few million years instead of billions. And when even the helium runs out in the red giant's core, well, then the process of core contraction, sulfate dilatation, and so on repeats itself, only with the helium and heavier elements instead of hydrogen, and the star expands itself, becoming a red super giant. Betelgeuse is in this phase, at the end of it actually. It's made of, by now, of onion layers of heavier and heavier elements, but it's not able to fuse elements heavier than iron, so its core is an iron one by now. When this iron core finally reaches a mass about 1.4 times that of the Sun, the so-called Chandrasekhar mass, by the name of the Indian-American astrophysicist who calculated it, well, then the core collapses and two things happen. The first one is that the protons and electrons are so pushed together that they form neutrons and neutrinos, and though electrically neutral neutrinos usually don't interact with matter, at such monster height densities they cause a gigantic outward pressure. The second thing that happens when the iron core collapses is that the outer layers fall inward. So there is an overall contraction of the star, but going on with the process, at the end of it the core stops collapsing because the neutrons get stuffed too tightly, and the outer layers eventually plow into the core itself, and so bang! And then the outer layers rebound, and this creates huge shock waves that runs outward. So, pal, the final result of the combination of the neutrinos' gigantic outward pressure and the just mentioned the shock waves going outwards is that what's out of the star's core is blown apart in a humongous explosion 10 billion times more luminous than the Sun, as bright as entire galaxies for weeks, and that takes months or even years to fade away. Yep, pal, I'm describing a supernova. Well, a type 2 supernova to be precise. And, dear listener, to put there some more infos, the immense amount of energy released in a supernova is enough to fuse elements heavier than iron, therefore is what creates things like gold, silver, zinc, uranium, and so on, which in turn spread through space and end up being part of planets like your beloved Earth. And if you are asking yourself what happens to the core of the star after the final explosion, well, dear listener, that depends on its remaining mass. If the core mass is less than 2 or 3 solar masses, then it gets to be a neutron star. But if the residual mass is more than 2 or 3 solar masses, then it becomes a mighty infamous black hole. So, dear listener, to super sum up, red supergiant like Betelgeuse should not be dimming, and astronomers and their colleagues' space brains are puzzled by that. P.S. Anyway, in the last month or so, the playful star apparently has regained some of its shine. Okay, dear listener, that's all. I'm working already on a new regular episode where I'll tell you a science story about food and cities. Until then, please remember to, if you feel like to subscribe and or rate this podcast and or leave a comment on the blog and or take a tour of my stuff and go SNG eShop on Zazzle.com so you can see if there's something you like, and or support this project by clicking on the donate button on this dumb blog's homepage and making a donation. Take care, pal, stay safe, and ciao!
Science man, come out and play. Science man, come out and play. Science man, come out and play.
This is a podcast by sciencemag.com.